Hi everyone. In this lecture, we will discuss linear convolution using graphical method. So let's understand the process by the help of one numerical. So the question will come like determine the convolution sum of two sequences, and the two sequences are x of n and h of n, where x of n is given as 4, 2, 1, 3 and h of n is given as 1, 2, 2, 1, and this arrow represents the value at n is equal to 0. Hope this much is clear to you. So to perform linear convolution using graphical method, the following steps should be followed. Okay, so let's understand this step by step, so it will be easy for you to do this in exam. Fine. So what is the first step? So in the first step, start by selecting a specific time point denoted as n to evaluate the output sequence y of n. Okay, so basically nothing, you want to get to know about the starting point for y of n. Okay, so to determine this, consider the starting points of the input sequences x of n and h of n. So if x of n starts at n is equal to n1 and h of n starts at n is equal to n2, then choosing n is equal to n1 plus n2 would be a suitable option for y of n. It means what? Let me show you. So basically here we are dealing with convolution of finite sequences, right? So we already know what is the length of x of n. So in x of n, how many samples are present, boss? 4 samples are present, right? So length of x of n is what? 4 samples. So let's say it is equal to what? Capital N1. Now length of h of n. So if you see h of n, this is h of n, 1, 2, 3, 4 samples. So in h of n also, how many samples are present? 4 samples are present. So 4 samples. Clear? So this becomes what? Equal to what? N2. Clear? Now the length of resultant sequence. So what will be the length of resultant sequence? So basically it will be equal to N1 plus N2 minus 1. Okay. So basically what is N1 here? 4. So 4 plus N2, 4 minus 1, which is basically what? 7 samples. Am I right? Which is basically what? 7 samples. So it means what? Y of n will have n is equal to what? 7 samples. So that we understood, like y of n will have how many samples? 7 samples. Clear? Now let's go for the next starting point. So basically x of n starts at n1. Okay, and we already know that x of n starts at what? 0, right? And h of n starts at n2 is equal to what? So if you see h of n, so this is h of n, it is starting from here, right? So this is n is equal to 0 term, so this is what? N is equal to minus 1 term. So basically h of n is what? Starts at n2 is equal to minus 1. Am I right? Therefore the starting sample of y of n is what? The starting sample of y of n is what? We saw just now, right? N is equal to n1 plus n2. That is what we discussed in the theory also. So this will be equal to what? N is equal to n1 plus n2. So what is n1? 0. What is n2? Minus 1. So overall it will be what? Minus 1. Fine. If you want to calculate the end point, so y of n ends at what? N is equal to, there is another formula which is what? n1 plus n2 plus capital N1 plus N2 minus 1, okay, and whole minus 1. So from here this is what basically So if you focus on this particular portion, this is giving you what? Minus 1, and this is what? Basically 7 and minus 1. Okay, so it becomes what? Minus 1 plus 7 minus 1. It means overall n is equal to what? 5. So this is what? Y end at n is equal to 5 and y will start at n is equal to minus 1. So from here, what is the conclusion, boss? The conclusion is y of n will have 7 samples. We have already calculated, that is from n is equal to minus 1 to n is equal to 5. Okay, so this is the first step. You should know the starting point for y of n and how many samples we are going to get. That part also you should know. So okay, step 1 is clear. Fine, let's go for the next. Fine. Okay, so basically another way I'm going to show you to solve this, the first step. So we already know, you already know that y of n will have 7 samples. We have calculated, right? So if y of n starts at n is equal to what? Minus 1. This also we have calculated. So we are not required to calculate the end point by that formula. Okay, it is a common sense. If it is having 7 samples and the starting point is what? Minus 1, it means minus 1, 0, right? Then 1, 2, 3, 4, 5. 7 samples completed. So it will end at n is equal to 5. Clear? Okay. Now what else? So the response y of n of the system is given by convolution of x of n and h of n. This also we know, right? And y of n is given as what? Convolution of x of n and h of n, and the formula is what? Summation of x of n, okay, into h of n minus m over the limit m ranges from minus infinity to plus infinity. So hope it is clear to you. Fine, let's go for the second point, or you can say second step. So first step is clear. We calculated starting point for y of n, we calculated how many samples will be there in y of n, and we calculated y of n end point. So these three things are the part of first step. If you understand this, it will be easy for you to go further. Fine. Now the second step, represent both input sequences, I mean x of n and h of n, in the terms of index m. Okay, this allows us to visualize the sequences on a graph. So simply you have to change n by m. So x of n will become what? X of m, and h of n will become what? H of n, and just plot it. So you are already expert in plotting the graph, right? If the sequence representation is given, we can plot the graph easily. So x of n is this, so we have to change the index, so it will become x of n versus m. So if you see, for this is a graph, okay, for x of n, this is a graph. So at 0 and m is equal to 0, the value is what? 4. Okay, at m is equal to 1, the value is what? 2. At m is equal to 2, the value is what? 1. And at m is equal to 3, the value is what? 3. Okay, it is defined for this instances only. Other places it is what? 0. Fine. And now let's plot a graph for h of m. So h of m, this is what? H of m versus n. So at it is h of n is starting from minus 1, so it will also start from minus 1. So at m is equal to minus 1, what is the value? 1. At m is equal to 0, what is the value? Was 2. At m is equal to 1, what is the value? Again 2. And at m is equal to 2, what is the value? 1. So I hope these two graphs are clear to you. Nothing is there. This is given. We have to just change the index. So it will become what? H of m, and you have to just plot this graph for h of m and x of m. That's all. Fine. Now let's see the third step. This step was easy, right? Fine. In the third step, what you have to do? You have to fold this impulse response h of m about m is equal to 0. You have to fold it. Then you will obtain what? H of minus m. Clear? Now sketch the graphical representation of the folded sequence. So this is what you have to do in step 3. So fold the impulse response h of m about m is equal to 0 to obtain h of minus m, and then sketch the graphical representation of the folded sequence h of minus m. Hope you are already aware about the folding, right? If you don't know, you can refer our old videos, previous lectures. I have taught clearly about the folding of a signal. So basically you have to fold this and then you have to sketch. So this is how h of minus m looks like. So if you see this, you have to simply fold. This will come this side, this will come this side. So I have folded simply. Now I have this graph for h of minus m. So basically at m is equal to minus 2 you will get now 1, and in the original h of m at m is equal to 2 you are getting 1. So here at m is equal to minus 2 you will get 1. Now at m is equal to minus 1 you will get basically what? 2. At m is equal to 0 you will get 2, and at m is equal to 1 you will get what? 1. Or in a simple sense, see, h of m is what, boss? 1 comma 2 comma 2 comma 1. This is what? 0th location. Now if you want h of minus m, think like this, right from this angle. So 1 comma 2 comma 2 comma 1, and plot the graph. This is the graph for this. Am I right? I hope this is now clear to you what you have to actually perform. So this is what basically is step number 3. Okay. Now let's go further and understand this more. So basically let me start the picture now. So then what you have to do? Then shift this folded sequence to the right if n is what? Positive, boss, or to the left if n is what? Negative. This will give us the sequence h of n minus m, because we already know when you go for convolution then this term will come, right? So based on value of n you have to perform some sort of shifting. So basically y of n is this, we know this thing. So let's say I am going to represent this particular thing as summation of x of m, and I am going to represent this part as hn of m. Okay, just for representation purpose, don't worry. And the limit is what? M is equal to minus infinity to plus infinity. So here what we are doing? Where h of n m, hn of m is equal to what? H of n minus m. Hope it is clear to you. Okay. Now let's go for the fourth step. So in the fourth step, what you have to do? Multiply each element of the input sequences x of m with the corresponding element of the shifted impulse response h of n minus m. At the end, sum up all the products to obtain the output sequence y of n at that specific time point. Clear? So basically what you have to do, just hold on. Okay, I will explain you. So basically we have to start from n is equal to minus 1, right? So assume when n is what? Minus 1. So when n is equal to minus 1, then it will become what? Y of minus 1, right? So y of minus 1 will be what? Summation of x of m into h of, in the original expression it is what? N minus m. So here it will be what? Minus 1 minus m. Clear? Now we will represent this as h of h minus 1 of m, right? Because we are following this thing. So compare with this. See? So h of n minus m, right? So in the place of n, here we have minus 1. So this becomes this. And now we were representing this as this. So here n is what? Minus 1. So we are representing it like this. And at the end, whatever we get, we are going to sum up. We'll see this thing. Don't worry. So basically what you have to do, you have to plot x of m, you have to plot h minus 1 of m. Clear? This thing you have to plot, and then basically you have to multiply this 2. So let's plot and check. So basically x of m, we already know this is x of m. We already plot this, okay? And then you have to plot h of minus 1 minus m. So what is this, boss? The value of n is what? Minus 1. Am I right? So the value of n is negative. We already know if the value of n is negative, then the folded sequence will be shifted to left. It will be shifted to what, boss? Left. Which sequence? Folded sequence. Now it is minus 1. So what will happen if you go for folded sequence? Let me show you. So this is our folded sequence. Am I right? This is our original folded sequence. Now basically you have to shift this to left by 1 unit. So this will shift here, this will shift here, here, here. So it will now start from what? 1, 0, 0, right? That is why if you see this, see here, at 0 you will get 1 now, at minus 1 you will get 2, at minus 2 you will get 2, at minus 3 you will get 1. So just shifting this 1 unit to the left. That is what we did. Clear? Fine. Let's go next. Now we have x of m, we have h minus 1 of m. Now we have to multiply this 2. So if you want to multiply, you have to check the common instance. So, or the common point, time point. So see, 0 and 0 is the common time point only, right? So you can multiply 4 into 1. So 4. So in the resultant signal v minus 1 of m, you will get value only at m is equal to 0. Only at m is equal to 0. And what is the value? This 4 into 1. So 4. So this will be equal to what? 4. Okay. And you have to sum up whatever you will get here. Then you will get the y of n at that specific point, time point. So from here we can say like y of minus 1 is equal to basically this. So you have to sum up this. So basically if you see only one sample is there and the value is what? 4. So it will be equal to what? 4. So y of minus 1 becomes what? 4. This is how you have to do exactly. Okay. Fine. Now let's go to the next. Please keep drawing this along with me, so it will be easy for you, because I will refer the last graphs also. So if you don't have that, you will not understand. Fine. Let's go to the next. So next instance is what, boss? Next is you have to check at n is equal to 0. Am I right? So basically step 5. So now increment the index by 1. So we were at n is equal to minus 1. Now we have to check for n is equal to 0. So increment the index by 1 and shift the sequence h of n minus m to the right by one sample. Repeat step 4 to calculate the new value of y of n at the updated time point. Same we have to perform, nothing else. Okay. So basically this time what? When n is equal to 0. So it will become what? Y of 0. So basically there is no, n is 0, so it will become h of minus m. Okay, which we are representing as h naught of m. Fine. And the overall result we are going to represent as v naught of m. And then we will sum up and we will calculate the y of 0. That's all. So here what is required, boss? X of m is required and h naught of m is required. X of m we already know. This is the graph for x of m. Okay. H naught of m is what, boss? Simple h of minus m. We already know the plot of h of minus m, right? So this is what? H naught of m. So this is the plot. We already know this well in advance. We have already did. Now you have to multiply this. Simple. So when you multiply this, what are the common points, time points? See, 0, 0. Here also, this is also defined for m is equal to 0, this is also defined for m is equal to 0. So the resultant signal will be defined as at m is equal to 0, that is for sure. Now go to the next. At 1, this is also giving value, this is also giving value. So at m is equal to 1 also, this both will get value. So you can multiply this. So let's deal with m is equal to 0. So at m is equal to 0, if you see the value here, it is 4 and here it is 2. So 4 into 2 with what? 8, right? So at m is equal to 0, you will get 8 in the resultant signal, and another instance is what? M is equal to 1. So 1, here 2 is present, right? And here 1 is present, 2 into 1, which is basically 2. Understood? Now let's plot this V naught of m. So here we have the V naught of m. Okay, V naught of m. So if you see m is equal to 0, at m is equal to 0, the value is what? 8 boss, and at m is equal to 1, the value is what? 2. Now you have to sum up. So 8 plus 2, 10. Okay, so y of 0 will become what? 8 plus 2, which is what? 10 basically. This is what? Y of 0. Hope it is clear to you. Fine. Now let's move for the next. So y of minus 1 we got 4, and this is y of 0 we got 10. Fine. Let's go for the next. So next instance is what? When n is equal to 1. So when n is equal to 1, so y of 1 becomes what? Summation of x of m into h of 1 minus m, where the limit of m ranges from minus infinity to plus infinity. Now it is h of 1 minus m. So you have to represent this as what? h1 of m, right? And overall we know what to do here. We'll do this. Fine. So basically our main agenda here is first plot x of m, that we already know. So I have already plotted this. Then multiply this with h of 1 minus m, which is represented as h1 of m. So h of 1 minus m. So here the value of n is what, boss? Positive. So if the value of n is positive, then what you have to do? You have to shift to right, if n is positive. So see, basically if you see this particular plot, so this is what? See, h of minus m, right? So you have to shift this 1 unit to the right. Am I right? So that is what we are doing here. We are shifting that 1 unit to the right. So now h1 of m is this. So whatever we saw right, h of minus m, we shifted 1 unit to the right. So if you shift to the right by 1 sample, you will achieve 1 minus m, boss. Means this graph. Simple, nothing you have to do. Okay. That's why I said you should have the old graphs also. Then it will be easy for you to understood this. Fine. Now let's see the common point here. So m is equal to 0. For m is equal to 0, this is also defined, boss. This is also defined. For m is equal to 1, this is also defined. This is also defined. For 2, this is also defined. This is also defined. Now multiply this. So 4 into 2, 8. So at m is equal to 0, you will get the value 8. Okay. Now let's deal with next. So at m is equal to 1, the value will be what? Here it is 2, here it is 2. 2 into 2, 4. Now at m is equal to what? Basically 2, right? M is equal to 2. So m is equal to 2. What will be the value here, boss? So at 2, this is 1, and 2, this is also 1. So 1 into 1, basically 1, right? So you will get basically here 1. So you get 8, 4, 1. So now let's plot the resultant graph. So this is the resultant graph, which is represented by V1 of m. So V1 of m. So this is the plot. So at m is equal to 0, we got what value? 8. At m is equal to 1, we got value 4. At m is equal to 2, we got the value 1. And what we have to do? We have to perform summation of V1 of m, where the range of m is from minus infinity to plus infinity, but it is defined for these 3 instances. That is the reason, you know, you can sum up this 3 and that will be the result. Sum up this 3. So 8 plus 4, 12, 1, 13. So basically if you see y of 1, this will be equal to what? 8 plus 4 plus 1, which is what? 13. So this is what we have calculated, y of 1. Y of 1 is calculated successfully. Now let's go for the next. So next is what? Y of 2 you have to calculate. So basically we have to deal with this when n is equal to 2. Okay, so when n is equal to 2, y of 2 will become what? Summation of x of m into h of 2 minus m, when the limit of m is what? Minus infinity to plus infinity. So h of 2 minus m. So what you have to do? You can represent this as h2 of m. Okay, then you will get the resultant here. You have to perform this to get the result. Now the thing here is, we already know the plot of h of 1 minus m. Okay, h of 1 minus m. Just shift this to the right by one sample, then you will automatically achieve h of 2 minus m. Clear? So x of m plot we already know, and this is what we have to shift this to the right by one sample, so it will become this. Okay, so just multiply it. So in this it was giving the value 1 at 2, so now it is shifted by 1 unit to the right. Okay, so just multiply it. So to multiply it, you should know first what are the common instant. So if you see, at m is equal to 0, this is defined, this is also defined. At m is equal to 1, both are defined. At m is equal to 2, both are defined. At m is equal to 3, both are defined. So just multiply it and plot the final result. So basically final result is what? V2 of m. Okay, which is nothing but multiplication. So if you see here, at m is equal to 0, so this is 4, this is 1. 4 into 1, 4. So here in this final result, it will give you 4 at m is equal to 0. Now check for m is equal to 1. So at m is equal to 1, this will give you what? 2. This is what? 2. So 2 into 2, 4. So again for this resultant you will get here 4. Clear? Now at m is equal to 2 it is 1. At m is equal to 2 it is 2. 1 into 2, 2. So in the resultant signal, what you can write? 2. Now same, at m is equal to 3, this is giving you 1, and here 3, the value is 3. So 3 into 1, which is 3. So this is what? The result, V2 of m. But what you have to do? You have to sum up this. So you have to do summation of V2 of m, where the limit of m ranges from minus infinity to plus infinity, but it is defined for only this 4 instant. So just sum up, then you will get what? Y2 of y of 2, right? Y of 2 you will get. So 4 plus 4 plus 2 plus 3. So 4 plus 4 plus 2 plus 3. So 8, 10, 13, 13. So y of 2 we got the value 13. Clear? Fine. Now same way you have to go next and check for when n is equal to 3. So when n is equal to 3, it will become this. Okay, I am not repeating this. So what you have to basically focus? So you have to focus on, you already know x of m plot, right? And you have to plot here h3 of m. So h3 of m is what? You already know, boss. h2 of m here. This is h2 of m. Just shift it to the right by one sample again. This to the right by one sample. So you will get this plot. See, you will get this plot. So you have to multiply this with x of m. Okay. So you have to multiply this with x of m. You will get this result, V3 of m. So basically just plot x of m also. Let me show you x of m, some old x of m. So it will be easy for you to do this. Hold on. So basically here is my x of m. See, x of m. So it is having value at m is equal to 1, 2, and if you see this signal, it is also having value at 1 and 2 and even 3, and original signal is also having, means x of m is also having the value at 3. So common instances are what? M is equal to 1, 2 and 3. So you have to multiply, simple. See here, what you have to do. So at m is equal to 1, the value is 2 and 1 here. So 2 into 1, 2. So in this final plot, it will become what? At m is equal to 1, you will get 2. Now here, let's check for m is equal to 2. So m is equal to 2, here it is 2, here it is 1. So 2 into 1, again 2. Now check at m is equal to 3. So here it is 2, here it is 3. 3 into 2, 6. So you got here 6. Clear? Fine. So this is what? V3 of m. So what you have to do? You have to do a summation of this. So 6 plus 2 plus 2. So 6 plus 2 plus 2 is what basically, boss? 10. So from here we got to know that y3 of n is what, boss? 10. This is what you have to do. Fine. Let's go for the next now. Only two instances are pending, n is equal to 4 and n is equal to 5. So when n is equal to 4, so same thing you have to perform, nothing else, nothing extra. So x of m plot we already know here. This is x of m. You have to do a plot for h of 4 minus m. If you know already the plot of h of 3 minus m, just shift it to the right by one sample. So you will get this plot, which is basically nothing but h of 4 minus m represented as h4 of m. Now do a multiplication, check the common point. So this and this. So this signal is defined as m is equal to 2, and this is also defined as m is equal to 2. This is also at m is equal to 3. This is defined, and this is also defined as m is equal to 3. So these are the common point, right? So just do a multiplication for these 2 points. So the resultant signal, it will also give the sample at this instant only, the common instance. So m is equal to 2 and 3. And what will be the value, boss? So at 2, what is here? 1. At 2 here is 1. So in the final also, it will give 1 into 1, 1. Now at m is equal to 3. So here it will be 3. It is 3, right? And here m is equal to 3. The value is what? 2. So 3 into 2, 6. So here it will be 6. So this is what? V4 of m. Now you have to do a summation, right? See here, you have to do what, boss? Summation. Clear? So just sum up this. 6 plus 1, 7. Easy, right? 6 plus 1, 7. So y of 4 is what? Basically 7 here. You have to do this much only. I hope now you understood this thing. Now the last thing, that is what, boss? When n is equal to 5. When n is equal to 5. So you have to plot x of m, you have to plot h of 5 minus m, which is represented by h5 of m here. And you already know the plot for h4 of m. Just shift the same to the right by one sample, you will get this. And x of m you already know, and the multiplication of this is represented by v5 of m. Simple. And then you have to do the summation, you will get y of 5. That's all, boss. Now here check the common instance. So the common instance is what? M is equal to 3. I can see only one common instance, so 3. So v5 of m will also be defined at m is equal to 3. And what is the value? Here at 3 it is 3, here at 3 it is 1. 3 into 1, 3. So you will get here also what? 3. Clear? So overall, if you go and check, y5 is what basically here? 3, only one sample, right? So it will be equal to what? 3, boss. So you can say that y of n is what? So at n is equal to minus 1, we got what, boss? 4, right? So 4, comma, next we got 10. Okay, 10 we got at n is equal to 0. So use the arrow here. And then what we got? 13. Then again we got 13. Then we got 10. Then we got 7. Then we got 3 at last. Fine. Hope it is clear to you. So step number 6 that we already performed, right? So continue step 5 until the sum of the products becomes 0 for all remaining values of n. This indicates that the linear convolution process is complete. So tell me one thing, suppose you don't know the end point, suppose in that case. So if you go further at n is equal to 6, do you think you will get any common point here? It will start from m is equal to 5, then m is equal to 4, sorry, right? If you go next, n is equal to 6, so this particular signal will start from m is equal to 4, and here there is no value for m is equal to 4. So do you think there will be any common instance? No, right? So in that case, what will happen? The sum of products becomes 0. You will not get anything. So just stop it, right? So this indicates that the linear convolution process is complete. If you don't understand this, no worries at all. Better to calculate the starting point and ending point. It is easy for you to draw this and understand each and everything if you calculated both the instances. Hope it is clear to you. Now we already know y of n. So if in the exam the question will come for to solve this using the graphical method, then you have to plot the graph for this also, boss. For this also, don't leave, okay? So just plot a graph. So just what I did here, see, I also plot the graph. So I already know, if I already know y of n, it is easy for me to plot the graph, right? This is my graph. So better you should also plot the graph of y of n versus n, and we already calculated the value. So this is all about what basically the convolution, the linear convolution using graphical method. So if you have any doubt in this, you can ask in the comment section. Thanks for watching.